Hi, this is Tony Gondola from the New Mexico Museum of Space History in Alamogordo, and it's my pleasure to welcome you to the next production in our virtual Rocketeer Academy series. Enjoy! The Moon, the bright orb that has graced our skies with its soft light and ever-changing shape since long before the first humans. Our closest celestial neighbor, the Moon, has had a large influence on both our planet and on us. But do you really know it as a place? Come along as we take a tour of some of its major features, all of which are accessible through the smallest of backyard telescopes. Our first observation is best made with the naked eye or binoculars. If you find the thin crescent moon low in the west a few days after new moon, you'll notice that most of the surface is illuminated not by direct sunlight, but by light reflected from the Earth, a beautiful effect known as Earthshine. If you were looking at a full Earth from the Moon, it would be 37 times brighter and 4 times larger in the sky than a full moon seen from Earth. It would indeed be a magnificent sight. That's the source of the ghostly pale light you see. If you've taken more than a passing glance at the Moon, you'll have noticed that there are a number of dark patches scattered all over its surface. These are called seas, or the Latin version, mare. 3.8 billion years ago, the Moon suffered a series of incredibly large impacts. The impacting bodies were hundreds of miles across and first formed huge multi-ring basins, as shown here. Basaltic lava welled up through the cracks in the basins in a series of flooding events, eventually turning the basins into the relatively flat lava plains that we see today. The best example of this is the Imbrium Basin. Look for a large circular dark spot in the northwest quadrant of the Moon. It's best seen during the waxing gibbous phase 12 days after new moon, just a few days before it's full. Material thrown out from the Imbrium Basin impact can be found over most of the visible Moon's face. This event had a profound effect on the near and far side of the Moon. On the northern edge of the Imbrium Basin, you'll notice a large crater with a dark, smooth floor. This is the 62-mile-wide crater Plato. While relatively rare, some large craters on the Moon flood with lava just like the large basins, and that's what's happened with Plato. The tiny craters on its floor, the largest measuring only a mile or two across, are considered a test of telescopic resolution. How many can you see with your telescope? Just east of Plato, you'll notice a distinctive groove in the surface. This is the Alpine Valley. It's 103 miles long and 10 miles across at its widest point. This is a graben, or rift valley, that's been flooded with lava. There's also a sinuous rill running down the center of the valley. Rills are collapsed lava tubes, or channels, that are found in many places on the lunar surface. The most well-known example is Hadley Rill, which the Apollo 15 astronauts examined up close. In this case, the rill is only 1/3 of a mile wide and 250 feet deep. If you own a larger telescope, you might just spot it if the lighting is right. From the Alpine Valley, follow the curving line of the Apennine Mountains along the southeastern rim of the Imbrium Basin. If you follow the curve to the southwest, you'll come to the large crater Copernicus. This easy-to-find, 57-mile-wide, 2.3-mile-deep crater is a classic example of a complex crater. You may have already noticed that smaller craters have a simple bowl shape, but once the impact grows beyond a certain point, the inner parts of the crater floor rebound upwards, forming a complex of central peaks, while landslides and slumping of the crater walls form complex terraces. This oblique view from Lunar Orbiter 2 shows these walls in great detail. If you view Copernicus during a full moon, you'll also notice the extensive system of bright rays extending up to 800 miles in every direction. Copernicus is less than 1 billion years old, so all of these details are relatively fresh. When looking at the Moon during any phase, you may have noticed that most of the lunar seas are along the equator or north of it. The southern part of the Moon is just a jumble of craters, one on top of the other. This is known as the Southern Highlands and is the other major type of lunar terrain. Unlike the seas that are covered in basaltic lava, the highlands are the original lunar crust that has endured over 4 billion years of impacts, turning it into the rough, crater-saturated, jumbled terrain that we see today. If you think that the moon is brighter than it should be when it's full, you'd be right. A full moon is 10 times brighter than the half-moon phase. It turns out that the lunar soil is very good at reflecting light back towards the direction of the source. There are also minimal areas in shadow, so the entire surface is reflecting light. This is the time when you'll notice, along with Copernicus, the large number of very bright ray craters, both large and small, all over the surface. It's also worth mentioning that while the full moon looks far larger when it's close to the horizon than it does when it's overhead, this is just a quirk in human perception. Try looking at a rising full moon through a cardboard tube and the illusion will immediately vanish. The most prominent of the ray craters during full moon is the crater Tycho. Located deep in the southern highlands, the 65-mile-wide crater is very noticeable during full moon because of its very large and bright ray system, one of which can be traced right across the Imbrium Basin. Lunar rays are nothing more than streams of boulders and rocks, excavated and fractured during an impact and thrown out over very large distances. On the moon, freshly excavated material is brighter than the general surface and slowly darkens with age. A bright ray system is an indicator of a relatively recent impact event. In fact, Tycho is believed to have formed only 65 million years ago, roughly at about the same time as the impact that wiped out the dinosaurs. It may very well be the largest impact on the near side in recent times. I hope you've enjoyed this short tour of the lunar landscape and have a better feel for the moon as a real place. Of course, we have only scratched the surface of fascinating features to observe. The more time you spend looking at the moon, the more you'll see and understand. Familiar features will look different from night to night as the lighting changes, so it's always worth taking a look at our endlessly fascinating celestial neighbor. Well, I hope you've enjoyed our latest production in our Virtual Rocketeer Academy. Be sure to check back at this location for new productions and updates. And for now, stay home, stay safe, stay curious.